Okay, kiddos, here go answers to electrochemistry questions, practice for test. You should definitely have a reduction potential chart in front of you because we will be looking at this. So, looks like our lemon battery, and we are supposed to label all of these parts. So, here's what we had. We had a zinc nail, okay, and we had a copper penny. I'm going to look at the reduction potential chart, and I see that copper, the Cu2 plus, has a reduction potential of 0.34 volts, and looking at zinc, the Zn plus 2 has a reduction potential of negative 0.76. Okay, meaning copper was higher on the reduction potential chart, meaning it will be the one that is reduced. So, on your reduction potential chart, the higher up it is, the more likely it will to be reduced. The other one, therefore, is oxidized. Okay. So there was this mnemonic device, meaning a memory device that we talked about, and it goes like this: oil rig, which stands for oxidation is loss of electrons, reduction is gain of electrons. So oxidation is loss of electrons, whereas reduction is gain in electrons. So gain in electrons. Whoops. Gain in electrons. So what this means is that the zinc is going to lose electrons. Here are our little electrons, and they are going to go this way and flow towards the copper, because copper is going to gain electrons. Okay, so the current is flowing this way. Current, that's the way the electrons are flowing. This thing, of course, is the voltmeter. That's the little box device that we use to measure the voltage. And let's proceed with these other terms. Let's see, cathode and anode, what were those? So by definition, the cathode is the positive term and the anode is the negative term. I tend to remember that by, let's see, negative. So negative and anode, the N's there, help me remember that. And so if zinc is giving off electrons, electrons are negative, this will therefore be the negative terminal, and this will be the positive. Electrons being negatively charged flow towards the positive terminal. Okay. So we have negative, this is the anode, and this is the cathode. Okay, so kind of a lot to remember. And another way to remember this is that whatever is reduced is the cathode, and whatever is oxidized is the anode. And so it's described frequently as the vowels O and A go together, and the consonants R and C go together, to remember when you know what's reduced and what's oxidized, what to call it, the cathode or the anode. Because we will be doing different questions where it's not zinc and copper. We have two different metals, and we will be figuring out which is reduced, which is oxidized, what's the cathode, what's the anode, what's the positive, what's the negative terminal. Okay. Whew, so cathode, anode, positive terminal, right? Where was our positive? This was the negative terminal, this was the positive terminal. So we might make a little plus and a minus. What gets reduced? That was over here, the copper. What gets oxidized? That was over here, the zinc. The flow of electrons is this way, from the negative to the positive terminal. Electrolyte. Okay, so we used a lemon here because inside we have a bunch of ions, positives and negatives. This is actually acidic. Whoops, no. And so in here is the electrolyte. Okay, so the electrolyte is going to be some sort of solution with positive and negative ions that helps this chemical reaction take place. Voltmeter, that was here, measures the voltage, and then the wire, these things here would be wires. Okay, we need wire metal in order for the electrons to flow through it. Now, here's something new and important. When we go to actually find the voltage, okay, produced, you know from the lemon battery that it produced a little less than a volt. Maybe it was half a volt, but some of yours was up close to a volt. So what we do is from our reduction potential chart, you see these numbers that I wrote down? So this is the voltage basically of the copper reaction, and this is the voltage of the zinc reaction. Copper was higher on the chart, this was lower on the chart. So we basically take the high minus the low. So 0.34 minus this one, negative 0.76 equals, and plugging that in to a calculator is going to give me 1.1 volts. So if these reactions were running perfectly, we would need a really strongly acidic electrolyte with maybe some copper and some zinc ions in there, but we could get 1.1 volts out of that lemon battery. So the high minus the low, these numbers are on your reduction potential chart. That's how you find the voltage. We will be doing other questions like this soon. All right, so there's part one. I think we're going to have 2 more parts. Let's continue.